Hi, Assalamualaikum. My name is Raja Asmullah Biraja Hussein. So today I'm going to present about my final year project, which is IoT-based smart agriculture monitoring system, specifically for chili pepper plant. Okay, this is the outline of my presentation. So we will focus on the problem statement, objective, scope of study, literature review, methodology, result and finding, conclusion, and also recommendations. For the problem statement, chili pepper is one of the important ingredients that Malaysian people use for making food in their daily life. And the farmers are required to increase their production every single year since the demand for chili pepper keep on increasing. The traditional agriculture for chili require more laborers and it takes time to monitor the condition of the plant. Using the available sensor in the market, smart monitoring system can be designed to monitor the growth of the plant and the condition of the plant and the soil. It also can be monitored and controlled from the mobile apps. Okay, the objective of my project is to design a smart agriculture monitoring system to manifest a real-time monitoring system and control on a chili pepper plant using mobile apps. And then the second one is to develop the prototype module and test performance. Okay, there are three scopes of study, which is sensing, control, and communications. Okay, let's move to the literature review. For the first paper that I've read, titled A Comprehensive Review of Data Mining Technique in Smart Agriculture. So this paper talks about the large volume of data. So we need to explore fast and effective mechanism. So the mechanism that they use is wireless sensor actuator network (WSAN). This mechanism provides real-time monitoring and control for plants for precision irrigation based on data mining techniques. Okay, for the second paper, which is titled Smart IoT Water Sprinkler and Monitoring System for the Plant. The system using moisture sensor to capture the moisture of the soil and data will be processed in Arduino and microcontroller. Okay, they also use pH sensor, which is used to detect acidity or alkalinity for chili pepper plant, and EC sensor to determine the nutrition of the soil. So, as the result, uh, the data that they got is processed and sent to the internet shield, and then they can view it through mobile apps. So this is the another paper that I've read. I think I can't go through all of this because of the limited time. So if you want to see, you can pause. So we move to the methodology. This one is overall view that process tool I've used in my final year project. So we have literature review, preparation of sensor and material, cloud database setup, integration of system, visualization and monitoring design, and also finally system testing. Okay, for the preparation of material, we list out all the sensor and control machines. Okay, for all this, for the sensor, we use pH sensor, temperature sensor, humidity sensor, water level sensor, and also moisture sensor. And then the control machine, we control the water pump and also the nutrition. And then the second one, we choose the best cloud for better performance. Okay, for now I use TeamSpeak cloud as my cloud server. Okay, for the third one, which is determine the data that need to be stored in the cloud and the data need to be controlled from the cloud. Okay, the data that need to be stored in the cloud is the fast sensor that I talked about, and also the data need to control from the cloud is the two control, which is water pump and also nutrition. Okay, we move to the cloud database setup. As I said before, we're using the TeamSpeak as a cloud server. Okay, the third one which is integration of the system. This one we need the connection between the TeamSpeak and cloud, the TeamSpeak cloud and sensor. Okay, and the second one we transfer all the sensor data to the cloud. Okay, for the fourth is visualization and monitoring design. This one we use MIT inverter. So we designed the dashboard interface to X, and also we make the connection between MIT inverter and TeamSpeak database. And also we ensure that interface is easy and user friendly. Okay, the last one is the system testing. So we test out all the system flow, and if the any flaws, we try to troubleshoot it. This one is the smart monitoring system architecture. So basically we have 5 sensors that I said: water level, temperature, soil pH, soil moisture, and humidity. Okay, so all these 5 sensors are going to the TeamSpeak and stored in the TeamSpeak database. From the TeamSpeak, we extract the data from ThinkSpeed database and move it to the MIT Inverter mobile apps dashboard. Okay, from the mobile apps, we can control it with two controllers, which is watering plant and nutrition pump. So this one is the tools and software. So basically, you are using temperature and humidity sensor. You can pause to see the details. Okay, this one is the soil pH sensor. This one is soil moisture sensor. This is water level sensor. Okay, we are using Arduino Uno also. Okay, for visualization software, we are using MIT App Inventor. Okay, we move to the results and finding. So this is the prototype I have made. So all the sensors were attached to the prototype. The soil moisture sensor and the pH sensor were put into the pot to obtain the value of the water inside the soil and also the nutrition of the soil. And then the density sensor were attached to the container here, the silver container, to measure the temperature and humidity of the surrounding. And then the water level sensor are put under the water tank. In this case, we are using the bottle of water to measure the level of water inside it. We also have two motor pump, which is water pump, so for planting the water, and also to pump the fertilizer. So the black liquid here is the fertilizer. So we move to the cloud software. So basically, this is the part of coding that I use to send the data from Arduino to the cloud. So we are using the Wi-Fi module as a transmitter. Okay, so we focus on the string API. This is the essential part. The API is the API key that I get from the ThinkSpeed server. So we put the API key here to connect with Arduino. So this is the database of ThinkSpeed server. So there are 5 sensors that send from an Arduino to the ThinkSpeed cloud. Okay, for the field 1 chart, it is humidity. So in the average, we are having a 23% of humidity of the plant, and also for the temperature, it is 31 degrees Celsius. And then we move to the water level. As you can see here, at first it is 500, and then going up and also going down. Why? Because I'm playing with the water inside the water tank, which is at first I leave it there for a while, and it maintained as 500. And then when I put some water, it will increase to 750. And then when I remove the water, it will slowly decrease and eventually it will reach 0. Okay, for soil moisture sensor, the range is for 0 to 10. It reaches the what we call the conductivity of the soil. It's not the so when there are water, so the conductivity is increased. So where there is less water or no water, the conductivity will decrease. So as you can see, before that 0 is I put the sensor under the dry soil, so it reaches 0. When I pour water in that soil, so it will increase to 10.26. Okay, the last one is the soil pH. So the soil pH is 0 to 1. Due to some error, I just translate it from Arduino, which is 0 is greater than 5.6 pH, while 1 is less than 5.6 pH. As you can see, it is 0 because before that I just put some what we call raw soils on the pot, and then I put fertilizer in it, so the data will increase to 1. Okay, we move to the visualization software. So this is the MIT app inverter that I open using my smartphone. Okay, so basically there are 5 data here, which is water in water tank. It is the water capacity inside the water tank. So we have temperature, humidity, soil nutrition condition, soil moisture conditions. And we also have 2 green button here, which is to control it, which is plant fertilizer and also watering plant. Okay, for water in water tank, we make some construction of code inside the MIT Inventor, which is if the data that we got from the TeamSpeak database is 0, it will display empty. While if the data inside the database, TeamSpeak database, is more than 0, it will display full. Okay, for the temperature and humidity, we just take directly data that we got from the TeamSpeak server. Okay, for the soil nutrition condition, we also make some construction of coding inside MIT Inventor, which is if the value of the pH is 1, we will display good, which is less than 5.6. If the data that we got is 0, we will display bad, which is the value is greater than 5.7 pH. Okay, for soil moisture conditions, we also make some construction of coding inside the MIT Inventor, which is if the soil moisture is less than 1, it will display bad. If the soil moisture is greater than 1, it will display good.
Okay, to accomplish the second objective, which to develop the prototype module and test performance, we will move to the project demonstrations.
So this is my prototype. Okay, so we have water sensor inside the water. I assume this is the water tank, and then we have fertilizer. So this probe is for pH sensor, and then we have moisture sensor here. Okay, for DHT, for temperature sensor and humidity sensor, I put inside the container when I try to open it. Okay, so as you can see, this one is the DHT and temperature sensor. Okay, so I use the two motor here, as you can see, one for watering plant and then another one for fertilizer. Okay, so I put these two motor under the relay. So when I control it, then the relay works and it will control each of the motor. Okay, so this one is my Wi-Fi sensor in here. This is my Wi-Fi sensor, and then this is Arduino Uno. I use for Arduino.
Okay, on the right hand side is the mobile apps that I've made for this project. So basically we just click the go button here to start monitoring the plant. Okay, as you can see, there are 5 data that we have. Water in water tank is the water capacity inside the water tank. We have temperature, humidity, soil nutrition condition and soil moisture condition. We also have 2 control button, which is the green one. This button for plant fertilizer on the left hand side and watering plant on the right hand side. So let's say I click on the watering plant button. So the water is slowly pumped to the plant from the water tank. I made the video faster because it will take a while for the motor to pump the water. It will pump the water for a few minutes and then automatically off. So let's say if I click the plant fertilizer, okay, it will pump the fertilizer, which is the black liquid, to the plant.
So as a conclusion, implementing a system in cloud could be useful in most agriculture sector out there, as that they did not need to spend a lot of cash to manage their farm and did not require a lot of manpower to take care of their plant on site. So this study will help a lot of farmers out there to implement a cloud-based system on their plant. So there are a few recommendations that I need to improve on my project. Okay, firstly, the motor that I use is quite small, and then it is hard to pump the water to the plant. So I need to use the bigger motor to improve the plant, watering plant and nutrition plant. And then the second one is the water sensor. The water level sensor that I use now is to detect if the water is full or empty. It doesn't detect the medium or low. So I need for recommendation, I need 2 extra water level sensor to put one the total of 3. So the first is the at top of the water tank, and then the second one is the middle of the water tank, and then the last one is at the bottom of the water tank. So if the water reach the top, so it will display full, and then if the water reach the center, it will display medium, and if the water reach the bottom, it will display empty. Okay, that's all for me. Thank you.